In this podcast episode, Dr. David Sinclair, a Harvard professor and renowned researcher in aging and longevity, discusses groundbreaking scientific advances that suggest aging might not be inevitable. He explores how aging works at the cellular level, shares promising experimental treatments that have reversed aging in animals, and outlines lifestyle habits that may extend human health span. The conversation also addresses the societal, philosophical, and technological implications of significantly prolonged life, including the role of AI and future medicine. Dr. Sinclair begins by rejecting the long-held acceptance that aging is a natural, unchangeable part of life. He stresses that dying at the age of 80 is not a predetermined fate, but rather a biological challenge that modern science is now approaching with tools capable of reversing aging processes. With over 30 years studying longevity, he has witnessed lab results showing dramatic tissue age reversal. He insists the question is no longer if these breakthroughs will occur, but when. Dr. Sinclair points out that current common behaviors, such as smoking, excessive alcohol intake, flying frequently due to radiation exposure, and even attending loud concerts, accelerate aging by damaging DNA and cellular repair systems. Central to Dr. Sinclair's work is his information theory of aging, which posits that aging results from the loss of epigenetic information rather than from damage to the DNA sequence itself. DNA contains the genetic code, but epigenetics controls which genes are expressed in specific cell types. Over time, due to cellular stress and DNA breaks, these epigenetic signals become corrupted or erased, causing cells to lose their identity and function, leading to the symptoms of aging like gray hair, frailty, and organ decline. He compares this to a scratched vinyl record. While the music, genetic code, is intact, the scratches disrupt its play, gene expression. His groundbreaking insight is the discovery of a backup copy of youthful epigenetic information within cells, which can potentially be restored to reset cellular age. Dr. Sinclair's first human clinical trial, set to commence soon, involves injecting 3 genes into the optic nerve to rejuvenate retinal cells in blind patients. The eye is an enclosed, accessible system that allows for safer initial testing. These genes reset the epigenetic age of cells by about 75%, improving their function without reverting them to an embryonic state. In animal studies, including primates, similar gene therapies reversed aging in various tissues, such as brain and skin, curing conditions like blindness and neurodegenerative diseases. In mice, systemic delivery of these genes has doubled lifespan, effectively extending the remaining life of an old mouse equivalent to a human elderly person by 100%. This technology shows promise not only for age reversal, but for curing diseases intrinsically linked to aging, such as Alzheimer's, cancer, and heart disease. Aging is the underlying cause of most chronic diseases, from cancer to dementia. Dr. Sinclair emphasizes that by reversing cellular aging at the epigenetic level, diseases either disappear or can be cured because the body regains its youthful self-repair capabilities. Animal experiments demonstrate that inducing age reversal reverses symptoms and pathology of multiple diseases simultaneously, rather than treating each disease separately. This paradigm shifts the medical focus from symptom suppression to addressing the root aging process. Dr. Sinclair underlines that genetics plays only a minor role, 10 to 20%, in determining lifespan, while lifestyle and environment heavily influence the epigenetic aging rate. Major offenders that accelerate aging include smoking, excessive alcohol consumption, ultraviolet exposure, and frequent flying due to cosmic radiation. On the positive side, avoiding these risks alongside healthy eating, regular exercise, intermittent fasting, and fostering social bonds can prolong healthy life by up to 10 to 14 years. Importantly, one should avoid overprocessed foods and ensure nutrient-rich diets full of plants, polyphenols, and antioxidants. Having strong personal relationships or even pets is also correlated with slower aging. Dr. Sinclair explains that evolution prioritized reproductive success and early survival over longevity because most of our ancestors rarely lived beyond 30 to 40 years due to predation, disease, and environmental hazards. There was no evolutionary pressure to maintain bodily repair mechanisms beyond reproductive age. Species that live much longer, such as certain whales and bristlecone pines, generally face low predation, and have evolved mechanisms to maintain cellular integrity over centuries or millennia. Humans, freed from most predators today, are gradually evolving longer lifespans, but scientific intervention is needed for rapid progress. Fasting is a potent longevity intervention because it triggers hormesis, a biological phenomenon where mild stress activates cellular repair pathways, enhancing lifespan and health. When fasting, cells enter an adversity mode, turning on systems for DNA repair, protein recycling, autophagy, and inflammation reduction. Dr. Sinclair recommends gradually extending fasting intervals, starting with skipping breakfast, and occasional prolonged fasts of 2-3 days to activate deeper cleansing processes like chaperone-mediated autophagy. Exercise also invokes hormesis by challenging muscle and cardiovascular systems, with aerobic activity emphasized for maximal benefits. His lab's research has elucidated key molecules involved in aging regulation, including NAD, nicotinamide adenine dinucleotide, Sirtuins, enzymes controlling epigenetics and DNA repair, and polyphenols found in plants. NAD levels decline by half by middle age, impairing sirtuin activity. Fasting and exercise increase NAD and activate sirtuins, while polyphenols like resveratrol, quercetin, and compounds in matcha tea or blueberries amplify sirtuin function. These molecules work synergistically to maintain epigenetic information and promote cellular health. Dr. Sinclair also notes that excessive caloric intake shifts the body into abundance mode, reducing these protective responses and accelerating aging. Dr. Sinclair supplements his regimen with well-studied compounds like nicotinamide mononucleotide, NMN, a precursor that boosts NAD levels effectively in humans, spermidine derived from plants, glycine, an amino acid, resveratrol, and metformin, or its natural equivalent, berberine. He highlights the importance of vitamin D along with K2 for cardiovascular health, and sometimes low-dose aspirin, especially in individuals with genetic risk factors such as elevated LPA, a cholesterol-related protein linked to atherosclerosis. Aspirin's use is nuanced and should be personalized, but it can reduce clot risks in high-risk patients. Regular aerobic exercise that challenges cardiorespiratory capacity and strength training to maintain muscle mass are essential for longevity. Sauna use is supported by Finnish epidemiological studies demonstrating decreased cardiovascular mortality among frequent users, possibly through activation of heat shock proteins. Cold plunges may aid recovery and cellular stress resilience, but require further study. Red light therapy, including devices like red light caps, show promise for hair preservation and mitochondrial health. Dr. Sinclair's lab has found that cancer cells, like aging cells, experience a loss of identity and aberrant gene expression. By reprogramming cancer cells epigenetically through age reversal techniques, tumors can lose their malignant properties, sometimes self-destructing. While not a universal cure, this suggests that curing aging significantly reduces cancer risk and may transform oncology. Extending human lifespan raises complex social, economic, and ethical issues: workforce dynamics, social security, population growth, and meaning in life. Dr. Sinclair is optimistic that longer, healthy lives will enhance purpose and opportunities for personal growth, multiple careers, and deeper relationships. He rejects the notion that fearing death drives meaning, arguing that prolonged life simply extends moments of joy and agency. Innovations in aging intervention have attracted global government interest, with some investments and technologies blocked due to concerns over super soldier applications or geopolitical risks. Dr. Sinclair stresses that while the potential for weaponization exists, the benefits to public health and society outweigh these risks and calls for preparation for transformative societal changes. Human trials initiated in ophthalmology will determine whether gene therapy can safely reset cellular age and restore vision. If successful, this will pave the way for systemic treatments targeting multiple organs. Dr. Sinclair's lab is also developing orally available molecules discovered via artificial intelligence to make age-reversal medicines affordable and accessible worldwide. He predicts within decades, people will routinely take pills every few weeks to rejuvenate cells and extend lifespan well beyond current expectations, potentially into the 22nd century. Towards the end, Dr. Sinclair delves into philosophical reflections, expressing belief in a scientific form of spirituality informed by quantum mechanics. He discusses consciousness as a self-aware process, heavily influencing observed reality at the quantum level, and acknowledges the possibility humanity exists within a simulation. These perspectives underscore his wonder about the nature of existence and the underlying purpose of life. Dr. Sinclair launched a podcast called Lifespan to make longevity science accessible to the public and aims to build a global community where individuals learn from each other and accelerate collective understanding. He encourages public engagement and informed discussion as critical elements to prepare society for the coming medical revolution. Throughout the conversation, Dr. Sinclair encourages adopting practical habits like intermittent fasting, healthy diet rich in plants and polyphenols, regular aerobic exercise, avoiding harmful habits, and considering scientifically backed supplements. He advocates personalized medicine and early intervention rather than waiting to treat diseases after they appear. Emphasizing that extending health span should be a priority for all, he invites listeners to rethink aging as a reversible condition and to actively participate in the emerging longevity movement.